Okay, today we're looking at Module 3, Lesson 16, Symmetry in the Coordinate Plane. When you hear the word symmetry, do you think back to like pictures in elementary school? You would see a picture of a triangle, and the teacher would say, here's your line of symmetry, and if you fold the picture in half, everything would match and line up if you folded it along that dotted line of symmetry. And the reason everything would match up is because everything on this side is the same distance away from everything on this side. This is the same distance to there, and so on. If we looked at a square, that would have two lines of symmetry, actually more. So everything that if we folded it on the one dotted line, everything on the top and the bottom would line up, or the other one, the left and the right. So symmetry means everything on both sides of that line is the same distance away. I actually don't love this word symmetry for today's lesson. I'm going to give you another word later on. That'll be the word of the day for today's lesson. Okay, so let's take a look at this example on the board. You see 4 and negative 4 are circled on that horizontal number line. What do we know about 4 and negative 4? They're opposites. Why? What makes them opposites?
They're the same distance from 0.
They are the same distance from 0. So since 4 and negative 4 are both the same distance from 0, what do we know? They both have the same... They do have symmetry. They absolutely do. And I'm going to come back to that in a second. They have the same absolute value. Because they're opposite, they have the same distance. That distance is called the absolute value. They're both 4 units from 0. So if I drew a line here and folded it along those lines, would the 4 and the negative 4 match up?
Yeah.
Yes. What's another name for that line that goes through 0? That's the y-axis. So when we see opposites, that's actually called a reflection, like your reflection in the mirror, and that's our word of the day today. So if I looked at 4, positive 4, and reflected it over the y-axis, I would have negative 4. If I took negative 4, reflected it over the y-axis, I would have positive 4. So that's all that is. Let's take a look at this vertical number. Whoops. Let's take a look at this vertical number line. I see here positive 1. If I reflect that over the x-axis, what do I get? Negative 1. If I take negative 1 and reflect it over the x-axis, I get positive 1. So that's just another way to look at opposites. Opposites are also called reflections. Okay? So let's take a look at page 60 in your manual. In your module booklet, look at page 60, and there's a big, huge chart. We're just going to focus on that first column. So look at the top of the first column on page 60. There's 2 coordinates there. Circle the 2 coordinates. We have 3, 4, and negative 3, 4. You don't have a coordinate grid in your module, but I put one on the board just to help us. So here is 3, 4, and here is negative 3, 4. Okay? So let's look at what's the same and what's different, similar to what we did for last night's homework. Okay, they are both, but let's be more specific. Instead of saying they're both the same distance from 0, let's say they're both the same distance from the y-axis. But let's get more specific. 3 units away from the y-axis. What else can we say? What else is the same? Coordinate, exactly. So they have the same y coordinates, and the x coordinates have the same absolute value. I like what we said better. And we said that they're both three units from the y-axis. And that 3 units is their absolute value. I'll make that bigger so you can see it, so you can copy it in your notes. So they have the same y coordinates. The x coordinates have the same absolute value because they are both 3 units from the y-axis. All right, so now let's continue and look at how they are different. How can we say those coordinates are different? They are totally in different quadrants. That's, we're going to put that down about their location. I'm going to hold on to that one, but you're right. What else about the coordinates? The 2 points. Mike?
One is negative and positive.
What part of it is negative or positive?
Coordinates.
So they have different x coordinates. And what else can we say about the x coordinates? One is on the left of the y-axis. One is on the right of the y-axis. So that means the x coordinates are opposite numbers. So nice and simple, the x coordinates are opposite numbers. Now we're going to look at how their locations are similar, meaning like where we would find them if we had to give directions. Oops. So both points are 4 units above the x-axis, and they're both 3 units away from the y-axis. And look at the extra detail that was put in the answer. How many units? 4. Is it above or below? Above. And how many units away from the y? 3. We just can't say if it's left or right because one is the left, one is the right. So the locations are similar because both points are 4 units above the x-axis and 3 units away from the y-axis. So how are their locations different? You had said it earlier, the location is different because they are in different. And what else? How else are they different? One is how far to the right? 3 units to the right. One is 3 units to the left of the y-axis. And like we said, they're in different quadrants. And finally, the relationship between the coordinates and the location. Now they gave a really long, hairy, detailed answer. But basically what we want to look at is that they both have the same y coordinate, and what's different? The x coordinate. So because the x coordinates are opposite, do we see that? The x coordinates are opposite, so it was a reflection over the y-axis. So because the y coordinates were different, it's a reflection on the y-axis. And that's what I want you to focus on for your answer, that part right there. Whoops. There we go. Okay, because the x coordinates are opposite, it is a reflection over the y-axis. Okay, so because we have some time constraints, we're going to skip the next two rows. But we can just take a peek at the coordinates. For the next one was positive 3, positive 4, positive 3, negative 4. Since my y coordinates were opposite, it's a reflection over the x-axis. The opposites, 4 and negative 4, are the same distance away from the x-axis, so when the y coordinates are opposite, it's a reflection over the x-axis. Let's take a look if it's positive 3, positive 4, negative 3, negative 4. That was reflected over the y and then reflected over the x. Or we could have reflected it over the x and then reflected it over the y. But when we have two reflections, we take the opposite of both numbers. And it doesn't matter if we do x then y or y then x. But when we have the opposites of both coordinates, it's a reflection over both axes. And so what I want you to do is take a look at these notes and copy them if you have room on the bottom of page 60 or the bottom of page 61 or at the bottom of your problem set on page 62, or if you have room on the top of 59. My point is, copy this down. These are the rules that you want to remember. So to reflect over the x-axis, use the opposite of the y-coordinate. So the opposite of the opposite. So here, if we look at P, which was 2, 3, we took the opposite of the y-coordinate, 3 to negative 3, and that was a reflection over the x-axis. So the rule for reflection over the x-axis is xy becomes x negative y. And to reflect over the y-axis, use the opposite of the x-coordinate. So here our original point was 2, 3. To reflect it over the y-axis, we had the opposite of the x-coordinate, which you can see highlighted in pink. So the rule for a reflection over the y-axis is xy becomes negative xy. And you should have all this written down, obviously not the pictures, but these 4 sentences you should have written in your notes. Okay, let's take a look at this chart on page 61. All right, so the first point that was given is point S, which is over here, which is 5, 3. So if I wanted to take 5, 3 and reflect it over the x-axis, so 5, 3 reflected over the x-axis is what point? Remember, to reflect over the x, I take the opposite of the y. So that would be 5, negative 3. And what point is that? What about if I took negative 2, positive 4, and wanted to reflect that over the x-axis? What would that be? I have to take the opposite of the y. Opposite of y, if that helps you. So 3, negative 2 would be 3, 2. That was point M on the graph. So for the first column, we had the coordinate grid to look at. So for negative 1, negative 5, a reflection over the x-axis would be negative 1, positive 5. So to reflect over the x, we take the opposite of the y. See, opposite of the y, opposite of the y, opposite of the y, opposite of the y. And the x stays the same. Reflect over the x, keep the x. So now let's try reflecting across the y-axis. So that means we take the opposite of the x coordinate. So let's go back and look. Our first one we have a coordinate grid for. So if we're going to reflect that across the y-axis, that brings us to point L, which was -5, +3. So to reflect over the y, we keep the y and take the opposite of the x. So -2, +4 becomes 2, 4, -3, -2, and +1, -5. To reflect over the y, we keep the y and take the opposite of the x. Now, we're going to do a double reflection. I know. You ready? So first we'll reflect over the x and then reflect over the y. And we end up at point A, which is -5, -3. So if we're reflecting over two axes, we take the opposite of both coordinates. Two reflections, two opposites. So -2, -4 would be 2, -4. -3, +2, and 1 and 5. I'm taking the opposites of both coordinates. But that's when we reflected over the x and then the y. Suppose we reflected over the y first and then the x. Does it bring us to the same spot? Yes. So two reflections, two opposites, and it doesn't matter which way you reflect first. So this is still -5, -3. That's still 2, -4. That's still -3, 2. And that's still 1, 5. So if you're reflecting over the x, keep the x, take the opposite of the y. If you're reflecting over the y, keep the y, opposite of the x. If you're reflecting over both axes, you need the opposite of both coordinates. And it doesn't matter which axes you reflect over first.